So let's start by doing what we just did a minute ago and tracing our visual fields back to the retina. And when you do that on the right eye, as I said before, see that? The temporal visual field of the right eye projects to the nasal retina, and the nasal visual field of the left projects to the temporal retina of the right eye. You end up like that. Okay, it's just what we did before, no difference. And the same thing's going to happen with the left eye. The nasal visual field from the right side projects to the temporal retina on the left. And then the temporal visual field from the left eye projects to the nasal retina. Everybody good? Okay, so the easiest one to do is going to be the temporal retina. Temporal retina doesn't do anything fancy, so it's going to come down. The temporal retina from the right side comes down through the optic nerve, stays no change through the optic chiasm, and coming down the optic tract just goes straight down the road, and then is going to synapse here on the lateral geniculate nucleus of the thalamus. Okay, same thing, nothing tricky happens with the temporal retina from the left side. It comes all the way down through the optic nerve, through the optic chiasm, through the optic tract to synapse with the lateral geniculate nucleus of the thalamus. Okay, back to the right eye. The nasal retina are going to do something different. Nothing's ever easy, right? So what happens is the nasal retina from the right eye come down through the optic nerve, and when it gets to the optic chiasm, of course, it's going to cross over to the other side and synapse with the lateral geniculate, the contralateral lateral geniculate nucleus. Okay, so same thing's going to happen with the nasal retina from the left eye. Comes down through the optic nerve, gets to the optic chiasm and crosses over to the other side and synapses with the contralateral lateral geniculate nucleus. Okay, so at the level of the thalamus, what you have is that the left visual field is synapsed with the contralateral thalamic nucleus. And the right visual field, all of it, synapsed with the contralateral lateral geniculate nucleus. Everybody see that? It's because we did some crossing over there. Once we get to the level of the lateral geniculate nucleus, we're going to split up into two different tracts. So right now, at the level of the thalamus, we're separated into left and right visual fields, right? And they're opposite each other. So what's going to happen at the level of the thalamus, there are two more tracts that are going to be produced that are responsible for top and bottom. So superior and inferior quadrants. So not only is there left and right, there's top left and right and bottom left and right. So 4 visual fields you have to worry about. Okay? So coming out here, it's going to happen bilaterally from the lateral geniculate nucleus. You're going to have some axons. They're going to kind of swing way out, and they're going to synapse up here in the superior portion of the occipital lobe. Okay, so I'll make 3. In reality, this is overly simplified, but realize there's a lot of different axons that are coming out here. But all of these axons are going to synapse in the superior portion of the occipital lobe. Okay, that's going to happen on the right side, and it's also going to happen on the left side. So these kind of swing way out here. Synapse in the superior portion of the occipital lobe. And they're synapsing with the superior portion of the occipital lobe, but they are known as the inferior optic radiation. Okay, so these guys that swing way out here, these are the inferior optic radiation. And in addition, so I said it divides, believe it or not, the inferior optic radiation carries information about the upper quadrant. And then we also are going to have a superior optic radiation that is below the inferior optic radiation. So axons from the lateral geniculate nucleus are going to come out here and synapse with the inferior portion of the occipital lobe. Okay, so they just come straight on down. So you have the inferior synapses up high in the occipital lobe, but the superior optic radiation synapses in the inferior portion of the occipital lobe. Whoops, that was just a scratch. See that? Superior optic radiation. So, left and right visual fields kind of split up from the right eye. You see a little bit of the left, all of the right. That information comes down the temporal retina, doesn't cross over, comes right on down the optic nerve, optic chiasm, through the optic tract to synapse with the lateral geniculate nucleus. The right eye, the nasal retina, comes down the optic nerve, crosses over in the optic chiasm, synapses with the contralateral lateral geniculate nucleus. Same thing happens with the left eye. Temporal retina comes straight on down, nasal retina crosses over, synapses contralaterally. End up with left and right visual fields, reverse. Okay. From there, at the level of the thalamus, 2 different radiations appear. The first radiation is your inferior radiation that synapses with the superior occipital lobe. And then the second radiation is your superior optic radiation, and that synapses in the inferior portion of the occipital lobe. Questions? Good? All right, let's go ahead and